Hey, Miss Marion here. We're going to talk about volume of cylinder, cone, and sphere. So kind of a review in a way. And we're also going to be finding missing sides and also kind of talking about different things that we can see with the volume and that kind of stuff. So make sure you have a note page. And then also we're going to be doing a worksheet after. So make sure you have a worksheet. All right, so the top of our page says the volume V of a cylinder with radius R is given by the formula. So we did this formula last Thursday. And it so that the V equals pi r squared height. So that's the formula. We've looked at it. And they say the volume of the cylinder with radius of 5 is 50 pi cubic units. This 50 pi is it's another way of actually showing our volume without having the decimals, because they have it multiplied in the pi. And what they have is they actually put it together for us. So we have it as our volume. So if you look at it, they filled it in. This is our volume. This is our radius squared times pi times height. And then we got this, this equation here. And it says, what does the height of the cylinder have to be? So so think about it for a second. See if you can find an answer, and then we're going to actually kind of work through it and find out what the height should actually be. So we have 50, we have pi, right? And then we have 5 squared. What is 5 squared? That's 25 times pi and then times height. So if we look at it, this final answer is 50 pi. I have 25 times height. Well, actually, let's move that around. Let's do 25 times height times pi. And then we still have that 50 pi. So pretty much what we're doing is what multiplied by 25, so what number for height multiplied by 25 makes the 50? Because notice how there's pi already there. We really want to make a 50. So let's think about it for a second. What number multiplied by 25, or what's 50 divided by 25? Oh, that height is actually going to be 2. So let's try it. So is 25 times 2 times pi. 25 times 2 is 50. So notice how the 50 pi is the same as this 50 pi up here. So it's just another way of actually solving for that height. We've actually done it through the decimal kind of stuff. Now we're actually doing it with just having the pi symbol sitting there. And so our height here is 2. So we know that the height is actually 2, but I'm going to also show you a different way of actually solving this. So I'm going to put this kind of over here in red. So I have 50 pi equals 5 squared times pi times height. Okay. And so we still have 50. That was the highlighter. Hold on a second. So I have 50 pi equals 5 squared is 25 times pi and then times height. Notice how there are 2 pi's on both sides. If I divide by pi on both sides, we've done this kind of before, they cancel each other out. They make 1. So I have 50. Oops, let's do it in blue so it doesn't come, so we know that we have the same thing. So I'm going to do this in blue. So I have 50 left over. I have 25, and then I have times h. All right, so let's go ahead and solve for h. We've been doing this for a while, right? It's multiplied, so we're going to divide. So then I have 50 divided by 25. That makes our 2. So this one over here, we just kind of thought about it. This one over here, we did it mathematically. And you're going to need to know this for the next question. So if you don't understand it, pause, rewind, and watch it again, and then keep on going. All right, let's read number 2. It says the volume of the cylinder with height. Oh, this is a little different. We have a height of 4 units, and this is the volume of 36 pi. And then they gave us this statement. And then we are trying to find out what the radius is. What does the radius of the cylinder have to be? So we're going to kind of solve this like we did the second part of last time. And so we have radius squared times pi times 4, right? So notice again how there's pi on both sides. I'm going to divide by pi on both sides. I'm going to divide by pi, okay? Pi divided by pi, cancel each other out. We get 36 equals r squared times 4. Now, right now, I'm trying to get r squared by itself. So I'm going to divide. So notice how it's multiplied by 4. I'm going to divide by 4 on both sides. Grab a calculator. Let's do 36 divided by 4. Oh, that's 9. And 9 is going to equal r squared. Remember, r squared is what number multiplied by itself, right? So really what we're trying to think is what number multiplied by itself. So a radius multiplied by itself is going to make 9. That number, think about it. Oh, that number is 3. So r is going to equal 3 because 3 times 3 makes the 9. Because really what's the r squared, remember, technically is r times r. That's what that actually means there. Okay? Again, if you did not understand this, go ahead and pause it, rewind it, watch it again, and then keep on going. All right, so let's kind of remind us about what we did on Friday with our spheres. So again, our volume of a cylinder, so we need to know that, is 251.2 cubic feet. We have a radius of 2, and we're trying to find the height. So a cylinder, so V equals pi times radius squared times height. All right, and then, so our volume is 251.2 equals, we still have our pi. Again, our radius, they said our radius was 2, so we're going to have 2 squared times height. Remember, on Friday, we grabbed our calculator, and notice how there's not a pi on the other side, so we can't divide by pi, so we're going to multiply these together. So grab your calculator and put it in, so we're going to say pi times 2 caret top 2, right? Press enter, and our decimal should be 12.56637.061 times h, and then we have 251.2. And then again, how do we get to the h by himself? Because h is multiplying the 2.56637.062, right? These ones here are multiplying. So then we are going to divide, let's do green. Let's do black. Divide by 12.56637.061. Divide 12.56637.061. These two are going to make 1 and leave h by himself. So grab a calculator. We're going to do 251.2 divide 12.56637.061. And we're going to press enter. And we're going to get 19.9898686. And we are, let's round it to the nearest tenth. So let's just try that this time. So we're going to round it to the 10th. I'm going to look at the 8. Is 8 5 or above? Yes. Give the original a shove. So technically we're going to make this a 10, right? So eventually our answer is actually 20, and we need our unit feet, because it's feet, cubic feet, right? Equals our height. All right, here's another one except for so we have volume, cylinder is 157. We have a diameter of 5.2, and again, we're looking for the height. So our diameter is 5.2. So we're going to 5.2 divided by 2. So our radius, 5.2 divided by 2, which is 2.6. So we have it. So again, our formula is pi times radius squared times height. Our volume is 157. We have our pi. Our radius is 2.6 squared. Well, let's do it that way. Times height. So grab a calculator. Let's do pi times 2.6 caret top 2. And that's going to be 21.2371664 times height, and still the 157. Again, we want to go ahead and, whoops, sorry, 157. We want to head and we want to get height by itself because it's multiplying here. We are going to divide. Let's move this up. And we are going to go ahead and divide by the 21.2371664. Divide by the 21.2371664. So I'm putting in your calculator, 157 divided by 21.2371664. So our answer on that is 7.39270019 is our height. Let's round it to the nearest tenth. So we want the 3, we look at the 9. Is 9.5 or above? Yes, give the original a shove. So we're going to make it 7.4. Oh, we forgot our units. Let's try that whole thing again. So we have 7.4, and this is in feet for our height. All right, so here is our cone information, kind of like we just barely did at the beginning. So volume of a cone with a radius r is given by the formula v equals 1/3 times pi squared times height. And then they say the volume of the cone is a height of 3, and then we're looking for the radius, and then our volume is 64 pi. So height is 3, looking for the radius, and then this is our volume. So notice how they put it in. So they have 64 pi equals 1/3 times pi r squared times 3. And I'm just going to rewrite it so we can kind of solve it like we did before. And I'm going to go ahead and let's multiply together the 1/3 times 3. Grab your calculator. Let's do 1/3 times 3, and that is 1. So right now we have 1 times pi times radius squared, and then we still have our 64 pi. Notice how we have a pi here and a pi here. So let's go ahead and let's divide by pi on both sides. And so pi divided by pi leaves 1, leaves 64 by itself. Pi divided by pi is 1, and then we still have that 1, then r squared. And then yes, we know that 1 times anything is that same thing. So really we have 64 equals r squared. Now remember, r squared is take that number and multiply it by itself. So really what we're looking for is what number multiplied by itself makes 64. So let's kind of think about it. Oh, I know that 8 times 8 is 64. So 8 is going to be my radius. So again, if you don't understand this, go ahead and rewind it, go through it again, and then make sure you do understand it. All right, so let's go ahead and move on with some graphs, looking at graphs themselves. Notice how we have this one here. So this is height of a cylinder and its volume. So notice how this one's a cylinder and this one is a cone. And remember, a cylinder is pi times radius squared times height. And then this one is 1/3 times pi times radius squared times height. And so it is a cylinder and cone. Remember, they have association with each other. Looking at this graph, is it a function? So remember, we can go ahead, we can do our pencil test, our vertical line test, right? Does it only touch my pencil once? Okay, so is it a function? Oh, actually, I'll write it over on the side. So it's already there. Again, we're asking ourselves, so is this a, well, no, we'll do it this way. So is it a function? Yes. And then is this line linear? Remember, linear is a straight line. Yes, it is also. Now let's look at the cone. So again, we're going to do the vertical line test. So is this a function? Yes, it is. Is it linear? Does it make a straight line? Yes, it is. So notice as far as the cylinder and cone, they are both functions, and then they're also linear. All right, so we're going to go ahead and look at this graph. So again, is this a function? So if we look at it, This is a function, yes. Okay, it's because does it only touch my pencil once? You know, vertical line test. And is this linear? So it doesn't make a straight line? No, it is not. So again, we can kind of compare the different graphs themselves. If it makes like a swoopy sign, okay, this one is nonlinear, and then the other ones are linear. So here's the reason why I brought up that like scoopy line itself. So this graph, so if we read it, this is down on bottom. So this graph shows a relationship between a radius and the volume of many cones. All right, so this is cone whose height is 1.2 inches. And it says select all of the true statements. So the relationship between the radius and volume is linear. So on A, is this linear? No, it is not. It does not make a straight line. B, the relationship between radius and volume is not linear. This is yes. Okay, so select all the true statements, right? So B is an answer. If the radius of the cone doubles, the volume of the cone doubles. So let's kind of think about this. So down on the bottom, this is our radius. And side to side, it is the volume. Sorry, that didn't come in on our graph. So here we have this picture, and let's kind of pick 2 points. So, and we're going to kind of do a little bit thing on there. So if my radius is 2, what would be my volume? It would be 10. And then notice how it says if the radius of the cone doubles. So what is double 2? Well, that's 4. So the radius is going to equal 4. So I'm going to look at here. And that is about, so then my volume is probably about 61. So let's ask the question. So it says if the radius doubles, then the volume doubles. So the radius was 2, I doubled it to 4. What's double of volume? Of the 10, the volume. Is that 64? No, it is not. So is C true? No, it's not. So let's look at D. D says if the radius of the cone doubles, then the volume of the cone is multiplied by 2. So let's go ahead, let's try that again. So if my radius is 2, volume is 10, let's double the radius. So then my radius is 4. The volume that went with that, so the volume was 61. So it says that the answer should be multiplied by 2. So if the radius doubles, so that's 4, this should be multiplied by 2. Is that true? No, it's not. I'm going to put that in purple. All right. Now let's read the last one. If the radius of the cone is 2 inches, the volume of the cone is about 10 cubic inches. Well, this one is true. Yes, it is true. So these two answers are the two answers that go along with this graph. So I'm going to be honest with you, you're going to have something like this on your quiz tomorrow. So make sure you kind of understand how to read this graph, understand what goes along with it, okay? Again, if you don't understand something, pause it, rewind it, go through it again, and then figure it out. I will also be here this afternoon and tomorrow morning, okay? So today you are doing a worksheet of volume of cone, cylinder, and spheres. There are a couple of questions on there where you're trying to find the height of a cylinder given the volume and the radius. So we've done these things before to review. Again, please make sure you understand the things that are on the notes today. It's a little bit different because you do have a quiz tomorrow, and it's going to be, some of the questions are going to be kind of the same on your quiz tomorrow. So if you have questions, please come in tomorrow morning. I will answer some questions really quickly right before the quiz also. All right, so thank you. Have a good day. Bye.